Hey everyone, today we are going to explore strings in C programming. First, we will explore the fundamentals of strings in C. We will discuss how to declare and initialize strings, as well as how to assign values to them. Next, we will tackle the crucial skill of reading input from the user. We will learn how to read a line of text effectively in C. Moving on, we will explore the ins and outs of passing strings to functions. This is essential for building modular and effective code in C. Without further ado, let's get started. First, what are strings in C? In C programming, strings are sequences of characters stored in contiguous memory locations. Many programming languages like Java have a data type known as string for storing string values, whereas in C, it does not have a built-in string data type. In C, a string is stored as an array of characters. You have to use char data type and make an array of characters to create a string. In C programming, when a character array or a string is initialized using double quotes, the compiler automatically appends a null character which is \0 at the end of the string. This null character serves as a terminator indicating the end of the string. This is true for both statically allocated arrays and dynamically allocated arrays. For example, when you initialize a character array like this, the compiler allocates memory for an array of character that is large enough to hold the string cstring plus the null character. Now let's see how to declare a string in C. There are two ways, which are using char array and using string literal. The key difference between them is that in one method, we need to add the null character at the end explicitly, and in another, it is added by the compiler automatically. Now let's discuss them in detail. But before that, let's see the two methods which are used to define strings and characters in C. In C programming, when we want to represent a sequence of characters as a string, we enclose the characters within the double quotes, and this is known as string literal. For example, the word hello represents the string hello, and single quotes are used to denote individual characters. So when we enclose a character within a single quotes, it represents a character constant. In this example, h represents the character h. The double quotes method is a standard and preferred way of representing strings in C. So when you initialize a character array with a string enclosed in double quotes, like C string, the compiler automatically appends a null character which is \0 at the end of the string. So you don't have to do it yourself. Now look at the syntax. In this code, I declared a character array named C. The square bracket indicate that the C is an array. Since no size is specified inside the brackets, the size of the array is automatically determined by the number of characters in the initializer, including the null terminator. The initializer C string is a string literal enclosed in double quotes. It represents the sequence of characters C space string. The compiler appends a null terminator automatically at the end of the string literal. The compiler counts the number of characters in the string literal, including the null terminator. This count determines the size of the array. And if we want to represent a string using single quotes, we need to declare an array of characters where each character is enclosed in a single quote. In this method, it doesn't include a null terminator. Look at the syntax, and here we declared a character array named str and initialized with individual characters, which are h, e, l, l, o, which is followed by null terminator \0. However, this syntax is not commonly used for defining strings. Now let's understand the concept of declaring a string in C. And here is the general syntax. Char string name size equals string literal. Char is the data type for characters. String name is the name of the string variable. Size is the size of the character array. If it is not specified, the size will be automatically determined based on the length of the string literal. String literal, which is a sequence of characters enclosed in double quotes that represents the string. Look at the examples given below. In both cases, str1 and str2 are character arrays initialized with string literals, which represents the strings hello and world respectively. As I mentioned earlier, there are two ways to declare and initialize strings in C. The first method is char array or character array. In this method, we use a character array to represent a string. And in this method, we can specify the size of the array explicitly or let the compiler determine based on the length of a string. And here is the syntax and the example for declaring and initializing a string in C using char array. And I have already explained this. Now let's see the next method. In this method, we use a string literal, which is a sequence of characters enclosed in double quotes. Here the compiler automatically creates a character array to store the strings and appends the null terminator at the end. Look at the syntax. Char asterisk string name equals string literal. Char asterisk specifies the character pointer, string name, which is the name of the string pointer variable, string literal, which is a sequence of characters enclosed in double quotes representing the string. Look at this example. Here we declared a pointer to a character named str. This means str will store the memory address of the first character of the string. Next, equal sign. Here it is not an assignment operator, but rather it is used for initialization. World, this is the string literal, a sequence of characters enclosed in double quotes. It represents the string world. So when you assign a string literal to a character pointer like char asterisk str, the compiler automatically creates a character array to hold the string and initialize the pointer str to point to the first character of this array. So the main difference is how the null character is handled and whether the string can be modified after initialization. With string literals, the null character is added automatically and the string cannot be modified directly. With character arrays, you have to add the null character manually, but you can modify the string afterward. So once initialized, a string literal cannot be directly reassigned to another set of characters. For example, you cannot directly assign a new value to str like str equals world. Whereas in case of character array, it can be directly reassigned to another set of characters. For example, to update the value of str to world, you can assign each characters individually or you can use string manipulation functions. Here is an example for declaration and initialization of a character array and a string literal in C. First, we included the standard input-output library, which allow you to use functions like printf. Next, the main function, and here is where the execution of your program begins and ends. It returns an integer, 0 in this case, which indicates that the program has executed successfully. In next line, we declare and initialize a character array, which is named str array. The array is initialized with characters HELLO followed by the null terminator. This sequence of characters forms the string hello. In next line, we declared a pointer to a character named str literal. The pointer is assigned the memory address of the string literal hello. In C programming, the string literals are stored as array of characters and their memory address can be assigned to a pointer. In line 5 and 6, we use printf function to print the content of str array and str literal. %s is the format specifier for strings in printf. Str array and str literal are printed as strings, resulting in the output hello for both. And at last we have return statement. This statement ends the main function and returns 0 to indicate the successful execution of the program. Now let's run this program and you can see in the output, both methods result in the same string hello being printed. Now let's understand how to initialize a string in C. There are 4 methods, which are assigning a string literal with size, assigning a string literal without size, assigning character by character with size, assigning character by character without size. So when we assign a string literal with size, we declare a character array with specific size and directly assigning a string literal to it. In this example, we declared an array named str1 of type char with size of 10 characters. And this array is capable of holding 9 characters and a null terminator. Equals hello assigns the string literal hello to the array str1. The compiler automatically determines the size of the array based on the length of the string literal, including the null terminator. So in this case, the size of the array str1 is specified as 10 and the string literal hello is assigned to it. However, there is an important detail to consider. So the string literal hello contains 6 characters, which are HELLO and the null terminator \0. Since the size of str1 is specified as 10, which includes space for 9 characters and the null terminator, and only the necessary characters from the string literal are used, the compiler will pad the remaining spaces with null characters to fill the array. Assigning a string literal without size. In this method, you simply declare the array without specifying its size, and the compiler determines the size of the character array based on the length of the string literal. Look at this example. I declared an array named str2 consisting of characters. World is a string literal which is assigned to the array str2. Since we haven't explicitly specified the size of the array, so the compiler determines its size based on the length of the string literal, including the null terminator. The string world contains 5 characters and 1 null terminator. Therefore, the size of the array str2 will be 6 bytes, 5 for characters and 1 for null terminator. And next, assigning character by character with size. In this method, we initialize a string by assigning characters one by one with a specified size of the array. Look at this example. Here we initialized a character array str3 with size of 10 and assigns characters individually to form the string hello, followed by a null terminator to mark the end of a string. After these assignments, the array str3 contains the string hello and the null terminator, and remaining spaces in the array are left uninitialized. meaning that they could contain arbitrary data. And note that the null terminator is not automatically added to fill any remaining spaces in the array. It is only added after the last character you explicitly assign to the array, so that we can prevent buffer overflow errors. And finally, we have assigning character by character without size. This method is similar to previous method. Here we let the compiler determine the size of the array based on the number of characters assigned. Look at the syntax. An array named str4 is declared without specifying its size. The size of the array is automatically determined by the number of elements in the initialization list. Here the initialization list contains 6 elements, which are H, E, L, L, O and the null terminator. Therefore, the compiler determines the size of the str to be 6. Now let's see an example. And this code demonstrates the 4 common methods of initializing strings in C. First, include the standard input-output library, which allow you to use the functions like printf. Next, the main function. And here is where the execution of your program begins and ends. It returns an integer, in this case 0, which indicates that your program has been executed successfully. In next line, we assign a string literal with size. So here we declare a character array named str1 with size of 10 characters. The array is initialized with the string literal hello. The size of the array is explicitly specified as 10, which means it can hold the string hello along with the null terminator. And next we assign a string literal without size. Here we declare a character array named str2 without explicitly specifying its size. The array is initialized with the string literal hello. Since the size is not specified, the compiler automatically determines the size based on the length of the string literal, which includes the null terminator. And next we assign character by character with size. Here we declare a character array named str3 with size of 10 characters. The array is initialized by assigning characters one by one with the specified size of the array. It explicitly assigns the characters HELLO and the null terminator. Next up, we assign character by character without size. Here we declare a character array named str4 without explicitly specifying its size. The array is initialized by assigning characters one by one without specifying its size. Since the size is not specified, the compiler automatically determines the size based on the number of elements provided, including the null terminator. And finally the printing, and here we use printf statements to print the content of each string. %s is the format specifier for string in printf. And finally each string is printed along with its respective label. And finally we have return 0. This statement ends the main function and return 0 to indicate successful execution of the program. Now let's run this program. And you can see the output, it shows the string hello. Each line of output corresponds to one of the initialization methods, which demonstrates the different ways of achieving the same result hello. Now let's understand how to assign values to strings. You can assign values to strings in several ways. Here are some common methods. And it can be done using direct assignment and using string copy function, also by character assignment, and using sprintf function. In direct assignment method, you can directly assign a string literal to a character array. Look at the syntax. Here we declared a character array named string variable and initialized with the string literal. Char. This specifies that the variable string variable is an array of characters. And next we declared an array named string variable. Since no size is specified inside the square brackets, the size of the array is automatically determined by the compiler based on the length of the string literal being assigned. String literal, this is a string literal being assigned to the array. String variable, it contains the characters string underscore literal followed by a null terminator. Look at the example. Here we declared an array named str1 and initialized with string literal hello. The array size is determined by the compiler based on the length of the string literal. So the resulting str1 array will contain the characters HELLO followed by a null terminator. So in this method, the string hello is assigned to the array str1 at the time of declaration. Once an array is declared, you cannot directly assign a string to it using the assignment operator. Instead, if you want to change the value of the array later on, you can use the string copy function. So string copy function is used to assign a value to a character array by copying it. Look at the syntax. Char asterisk destination. This parameter specifies a destination character array where the content from the source string will be copied. It indicates that the destination array can be modified. Const char asterisk source. This parameter refers to a pointer to a constant character or a string literal. Here the content pointed to by the source pointer cannot be modified. The const keyword ensures the source string is unchanged during copying. The strcpy function or string copy function copies the entire content of the source string, including the null terminator, to the memory location pointed to by the destination pointer. It stops copying the characters when it encounters the null terminator in the source string, marking the end of the string. Look at this example. Here we declared a character array named str with capacity of 20 characters, and next we use the string copy function to copy the content of the string sho to the character array str. So the string copy function copies each character of the source string sho to the destination array str until it encounters the null terminator. The null terminator is also copied to the destination array. So after executing this code, the character array str will contain the string sho followed by the null terminator. The array str will have the length of 4 characters including the null terminator. And these are the most common methods used. Apart from these two methods, we can assign values to the string by assigning each character individually. Look at the syntax. In this method, we are assigning characters individually to the character array and null terminating the string. First, we declared a character array named string variable with maximum size of max length. And then we individually assign characters sho to the first, second, and third elements of the string variable array respectively. And finally, we assign the null terminator to the fourth element of the string variable array. And here is an example which demonstrates 4 different methods of assigning values to strings, which are direct assignment using string copy function, character by character assignment, and initialization at declaration. In this method, the string hello is directly assigned to the character array named strDirect at the time of declaration. This method is straightforward and commonly used. And then we use string copy function, which is used to copy the string world into the character array strcopy. Also, we used the character by character assignment. In this method, each character of the string sho is assigned individually to the character array strchar. And here the null terminator is explicitly added. Now let's run this code. In this part, the string hello is directly assigned to the character array strDirect at the time of declaration. The array is initialized to the specified string. When printed using printf function, it correctly displays the string hello. And in this part, we use strcpy function, which is used to copy the string world into the character array strcpy. This function copies the content of the source string world into the destination array strcpy. When printed using printf function, the strcpy displays the copied string world. In this part, each character of the string sho is assigned individually to the character array strchar. First, s is assigned to strchar0, then h is assigned to strchar1, and finally o to strchar2. After assigning these characters, the null terminator is explicitly added at strchar3, which marks the end of the string. And when printed using printf function, the strchar displays the assigned string sho. Overall, the output demonstrates the 3 different methods of assigning values to the strings in C, with its own approach and implications. Apart from these methods, we can use strncpy function, sprintf function, snprintf function, or even dynamically allocating memory using malloc. So with these methods, we can assign values to the strings. Now let's understand each method in detail. First, let's see sprintf function. Sprintf stands for string print. It is defined in stdio.h header file. It is similar to printf function. The only difference is instead of printing on console, it stores the output on the character buffer, which is specified in sprintf function. The sprintf function is the simplest method to convert integer, float, character, and double to the string value. So with sprintf function, we write the formatted data to a string. By using the %s format specifier, you can copy a string from one buffer to another. Now let's see the syntax. Int tells us that sprintf returns an integer value. Sprintf is the name of the function. Char asterisk str. This is the first parameter you pass to sprintf function. It should be a pointer to a character array. And here is where the result is stored. Const char asterisk format. This is a pointer to a constant string or a format string that specifies how you want the data to be formatted. The ellipsis indicates that the function can accept a variable number of arguments after the format parameter. Now let's see how the function call in the example aligns with the function signature, which is syntax. The first argument destination corresponds to the char asterisk str parameter in the syntax. It is a pointer to the destination buffer where the formatted string will be stored. The second argument %s corresponds to the const char asterisk format parameter in the function signature. It is a pointer to the format string indicating how the data will be formatted. In this case, %s specifies that the data to be inserted is a string. The third argument source corresponds to the additional data provided after the format string in the function call. So in this case, the source contains the actual data, which is the string hello, which is inserted into the format string. In simple terms, a sprintf function formats the data into a string and stores it in a buffer. And this function returns the length of the resulting string excluding the null character. If the final string exceeds the length of the buffer, the sprintf function may throw an exception. And next method is using strncpy function. The strncpy function is similar to strcpy function in that it copies the characters from one string to another, whereas strncpy function will copy a fixed number of characters from a source string to destination string. Look at the syntax. Char asterisk destination. This parameter is a pointer to the destination buffer where the copied string will be stored. Const char asterisk source. This parameter is a pointer to the source string that you want to copy. Size underscore tn. This parameter specifies the maximum number of characters to be copied from source string to destination buffer. The return type of strncpy function is char asterisk, which is a pointer to the destination buffer, and this allows you to chain function calls or use the result in further expressions. So strncpy function takes a destination buffer, a source string, and maximum number of characters to copy, and it returns a pointer to the destination buffer. Now look at the example. In the code snippet, the destination is the destination buffer where the copied string will be stored. Source is the source string that you want to copy. The function strncpy is used to copy the characters from the source string to destination buffer, and it ensures that no more than n characters are copied to prevent buffer overflows. So in this example, we allocate a memory for a character array called destination, which is capable of holding 49 characters plus null terminator. We initialize another character array called source with string hello. And here the compiler automatically determines the size of the array based on the length of the string literal. We use strncpy function to copy the characters from source array to destination array. We specify how many characters to copy from source to destination by using the size of destination array -1. After copying, we make sure to add a null terminator at the end of the destination array. And this ensures that the copied string is properly null terminated, indicating its end, even if the strncpy function did not copy the maximum number of characters. And next method is snprintf function. In sprintf function, we write the formatted data into a string without considering the buffer size. So this can lead to the buffer overflow if the string size is too long for the buffer. Whereas in snprintf function, you can specify the maximum number of buffer, and this prevents the buffer overflow. Look at the syntax. Char asterisk str. This is the pointer to the destination buffer where the formatted string will be stored. Size underscore t size. This parameter specifies the maximum number of characters to be written to the destination buffer, including the null terminator, and it helps preventing the buffer overflow by limiting the size of the output. Const char asterisk format. This is a pointer to a constant format string that specifies the format of the output. It contains the format specifiers like %s, %d, %f, etc. And it defines how the data should be formatted. And ellipsis indicates that snprintf function can accept variable number of additional arguments after the format parameter. The return value of snprintf function is integer, which tells you if the output fit into the buffer or the data was shortened because it couldn't fit entirely into the buffer. So in this example, char destination 50 declares a character array named destination with size of 50 characters. And this array is a destination buffer where formatted string will be stored. Char source equals hello. In this line, we declared another character array named source and initialized with the string hello. Here the size of the array is not specified, so the compiler will determine the size. In next line, we use snprintf function to format and copy the string from source to destination. The first argument, destination, is the destination buffer where the formatted string will be stored. The second argument, size of destination, specifies the maximum size of destination buffer, which ensures that snprintf function does not write more characters than the size of the buffer. The third argument, %s, is a format string, which copies a string from source array to destination buffer. The fourth argument, source, is a source string from which the data will be copied. So this code snippet uses the snprintf function to safely copy the string hello from the source array to destination array, and ensuring that the operation does not result in buffer overflow. And finally, we can assign values to the string using malloc function. And here we dynamically allocate memory for the destination string, and then we copy the source string into the dynamically allocated memory. So using malloc function, you dynamically allocate memory for the destination string, and we specify the size of the memory block based on the length of the source string plus one additional byte for the null terminator. Once memory is allocated, copy the content of the source string into the allocated memory. And it can be done using the string copy functions like strcpy, strncpy, sprintf, or snprintf. Look at the syntax. Char asterisk destination, and this declares a pointer variable named destination, which will point to the memory block allocated by malloc. The asterisk indicates that the destination is a pointer to a character, meaning that it will store the address of the first character of the dynamically allocated memory. Now look at this part. Malloc strlen source +1. And this part will dynamically allocate memory using malloc to hold a string. strlen source calculates the length of the source string, and +1 is added to allocate space for the null terminator. Char asterisk is a typecast. It is like a conversion that changes the pointer written by malloc into a character data type. In C, malloc returns a pointer of type void that can point to any data type. So when we allocate memory by malloc for strings, we explicitly convert this generic pointer to a character pointer. And this syntax dynamically allocates memory for a string using malloc and assigns the address of the allocated memory to the destination, which is a pointer variable. Look at the example. Char asterisk destination. This line declares a pointer variable destination that will store the address of the dynamically allocated memory block. Char source equals hello. This line declares and initializes a source string named source. And next line dynamically allocates memory for the destination string using malloc. And it allocates a memory for a string which is equal to the length of the source string plus 1 additional byte. And this additional byte is reserved for null terminator. And next, if destination not equal to null, this condition checks if the memory allocation was successful. If destination is not null, it means memory was allocated successfully. strcpy destination, source. This line copies the source string into the destination memory block. It makes sure that the destination string has the same content as source string. Overall, this code snippet dynamically allocates memory for the destination string and copies the content of the source string into it, and checks if the memory allocation was successful before copying. Now let's see an example that demonstrates the 4 different methods of assigning values to the string. In this example, we use sprintf, strncpy, snprintf, and malloc. First, include the necessary header files: stdio.h for input-output operations, stdlib.h for memory allocation, string.h for string manipulation, and then the main function, which is the entry point of the program. And next part is source string declaration. Here we declared a character array named source and initialized with string hello. Next, the destination buffer declaration. Here we declare a character array named destination with size of 50. And here's where we store the destination string. Next part is sprintf function. Here we use sprintf to copy the source string to the destination buffer. And this code prints both the source string and destination string that was copied using sprintf function. And next part we use strncpy function. The strncpy function copies the source string to the destination buffer, and it ensures proper null termination by manually adding a null terminator. Finally, it prints the destination string copied using strncpy function. In next part, we use snprintf function, and this function is used to copy the source string to the destination buffer with a specified maximum buffer size to prevent buffer overflows. And it prints the destination string copied using snprintf. And next part, we use malloc. Here we dynamically allocate memory for the destination string using malloc. It copies the source string to the dynamically allocated memory using strcpy function. And it prints the destination string copied using malloc. And finally, we free the dynamically allocated memory using free function to prevent memory leaks. And the return statement indicates the successful execution of the program. Overall, the code demonstrates the 4 different methods for assigning values to the strings in C using the functions like sprintf, strncpy, snprintf, and malloc. And each method is demonstrated with proper null termination and memory management. Now let's run this program. And the output shows that the source string hello was successfully copied to the destination buffer using 4 different methods. All methods resulted in the same destination string hello. Now let's understand how to read string from the user. To read a string from the user in C, you can use the scanf function, and it is the most common operation used for reading a string. It reads a sequence of characters until it encounters white spaces. In the given snippet, I have declared an array of character named str with size of 25. The next line, scanf, reads the string from the standard input and stores it in the array str. %s is the format specifier, which stops reading the input when it encounters white spaces. So it will only read the characters until the first white space character. Let's see how it works. First, include the standard input-output header file, which allow you to use the functions like printf and scanf. The next part is entry point of the program. Here is where the execution starts, int main. Here I declared a character array to store a string. The array name is str with size of 25. The next line prints a message which asks the user to enter a string. The scanf function is used to read the input and store it in the character array str. %24s is a format specifier which tells the scanf to read a string of characters until it encounters the white space, or until it has to read the 24 characters excluding the null terminator. str is the character array. Here is where the input string will be stored, and this printf function prints the string entered by the user. %s is the format specifier which is used to indicate that the string will be printed. Next, the return statement. which indicates that the program has executed successfully, and it returns 0 to the operating system. And finally, the curly brace marks the end of the main function. So this program prompts the user to enter a string, reads the input string using scanf, and then prints the entered string using printf. Let's run this program. I'm inputting the string sho space bina. The scanf function in this program reads only the characters sho and store it in the variable str, and the rest of the input bina is ignored. Now let's see how to read a line of text. The scanf function cannot read the strings with spaces, as it automatically stops reading when it encounters white space. So to read and print strings with white spaces, we can use the combination of fgetS and putS functions. The fgetS function reads a text line or a string from the specified file or console, and then stores it to the respective string variable. And this is the syntax for fgetS function. The char asterisk indicates the return type of the fgetS function. So in this case, it indicates that fgetS function returns a pointer to a character. fgetS is the name of the function. Now look at the parameters. Char asterisk str. This is a pointer to a character array where the string will be stored. It should be large enough to hold at least n characters plus one null terminator. Int n. This is the maximum number of characters to read, including any new line character. It specifies the maximum size of the buffer for reading the input line. File asterisk stream. This is a pointer to a file object representing the input stream from which to read the line of text. You can also read from files using fopen file pointers, not just from the keyboard with stdin. Look at the example. First, I declared an array named buffer capable of holding 100 characters. This array is used to store the input received from the user. And the next line reads a line of text from the standard input using the fgetS function. Buffer, size of buffer, stdin is the list of parameters passed to the fgetS function. Buffer is a pointer to the character array where the string being read will be stored. Size of buffer specifies the maximum number of characters to read. So which is the size of the buffer? So it ensures that fgetS function does not read more characters than the buffer can hold. stdin is the input stream from which to read the line of text. In this case, stdin represents the standard input stream, usually the keyboard. So when you call the fgetS function, you are invoking the fgetS function with these parameters, and it will return a pointer to the buffer containing the string read from the input stream. The char asterisk before the fgetS function indicates that the function returns a pointer to a character. The fgetS function reads the character from the input stream until one of the conditions is met. First, when n-1 characters have been read, and when a new line character is encountered, or end of file condition occurs. And next we have putS function. This function is useful for displaying strings. So with the help of putS function, we can display the string stored in the character array. Here is the syntax. It takes one argument. putS, this is the name of the function. Name of the string, this is the argument passed to the putS function. Name of the string is a string or a pointer to a character array, and it represents the starting memory address where the string is stored. The putS is a function that outputs strings. Look at this example. In this example, I initialized a character array named name of string with the string hello world. The next line outputs the stream stored in name of string to the standard output stream. So this line will output hello world followed by a new line character. Let's see an example that demonstrates fgetS to read a line of text and putS to display it. Hash include stdlib.h and hash include stdio.h. These are the preprocessor directives that include the standard library headers stdlib.h and stdio.h, which provides functions for input and output operations in C. Int main, this is the main function where the execution of the program begins. Char str30, this declares a character array named str with size of 30 characters, and this array will be used to store the input string. Printf, enter the string. This line displays the message enter string to instruct the user to input a string. The line 6 reads a line of text from the keyboard using the fgetS function. It stores the input string in the str array. Size of str ensures that the fgetS function reads at most 30 characters including the new line character. Line 7 prints the message the string is, which indicate that the enter string will be displayed. putS str. This line uses the putS function to display the string stored in the str array. The putS function automatically appends a new line character to the output, so the entered string will be displayed on a new line. Return 0. This line indicates the successful termination of main function. Now let's run this program. And the program prompting the user to enter a string. So I'm entering sho space bina, and you can see the program is echoing back the entered string. And we know that strings are character arrays, and it can be passed to functions like arrays, either directly or as pointers. So passing strings to functions can be done using character arrays or pointers to characters. Let's delve deeper into each method. In character array approach, the entire array containing the string is passed to the function. The function operates on the array directly. The array decays into a pointer to its first element when it is passed to the function. So when passing a character array to a function in C, you are not passing the entire array itself, but rather a pointer to the first element of the array. So here we think we are passing the whole array, but actually we are only passing a pointer to the first element of the array. Look at the syntax. Void specifies the return type of the function. In this case, the function doesn't return anything. Function name is the name of the function that you are defining. Char array name. This is the parameter declaration. Char specifies the data type of the parameter, indicating it's a character array. Array name is the name of the parameter inside the function. It indicates that the function expects an array of character as an argument. In pointer to character approach, a pointer to the first character of the string is passed to the function. The function accesses the string through this pointer. No array decay happens because you are passing a pointer explicitly. Now look at the syntax. Void specifies the return type of the function. In this case, the function doesn't return anything. Function name, name of the function that you are defining. Char asterisk pointer name, which is parameter declaration. Here char specifies the data type of the parameter, indicating it is a pointer to a character. Asterisk pointer name indicates that the function expects a pointer to a character as an argument. In both cases, you specify the data type of the parameter as char, indicating as a character type. In the first method, you are passing a character array. We use square brackets to indicate that the parameter is an array. In second method, you are passing a pointer to a character. So we use an asterisk, which indicate that the parameter is a pointer. In C, arrays and pointers have a close relationship. So when you pass an array to a function, it is actually passing a pointer to the first element of the array. Hence, both methods are quite similar in practice. And here is an example that demonstrates the usage of both methods of passing strings to function using pointers and using character array. And these parts are function definitions. Void pointer char asterisk str. This function takes a pointer to a character, that is char asterisk str as an argument, and it prints the string using putAs function. Void array char str square bracket. This function takes a character array char str square bracket as an argument, and it prints the string using putAs function. Int main, it is the main function where the program execution starts. Char str25 equals C is amazing. This part is declaration and initialization of character array str containing the string C is amazing. And this part is function calls pointer str. Here we are calling the pointer function and passing the string str as a pointer. Array str, we are calling the array function and passing the string str as a character array. Return statement, return 0 indicates the successful termination of the program. Now let's run this program. Both function calls prints the string C is amazing. The first function pointer receives a pointer to the string, while the second function array receives the entire character array.